Okay, so let's get on to the really exciting part. Let's see if we were able to replicate the original Keras paper. And we can see in front of me I've got my spreadsheet, which I've downloaded from Gorilla. In this case, there was only one task spreadsheet, because there was only one task element. So I've just opened that in Excel. And we can see there are lots of columns that in this case aren't really useful to us. A lot of the data to do with timestamps, dates, which operating system browser they were using, we don't really care about all that. We get to this point and we get the things that we're really interested in. So we can see, for example, their reaction time, we can see their responses, so we can see what they wrote down in the text entry box, and in the column correct, then we can see whether they were right or not. So anytime there's a 0 in that correct column, it means whatever they wrote was not what the actual word was. So we can see here they wrote the word heard, and if I go to answer, I can see the actual correct answer was the word module. But we can see down here, for example, they got it correct, so there's a 1. They wrote the word chief, which was the correct answer. Now, I mentioned as well in the spreadsheet, you can fill in columns in the spreadsheet that aren't driving your experiment, but they're going to be really helpful when it comes to analysing your data. We can see those have been included here. We have for each one of the trials what type of stimulus it was. Was it an audio stimulus or was it audiovisual? We have the condition, was it voice leading or was it a mouth leading stimulus? And we have the noise condition, was it a noisy stimulus or was it noise free? Now, to analyze all of this, I'm going to use a pivot table. Pivot tables are a really great tool in Excel, and you're going to see that with a couple clicks, we can get the data pretty much analyzed. Well, not analyzed, I should say, pre-processed. The analysis we're going to do in JASP. Normally, when you're creating and organizing your data, we like each row to be a participant, and then each column is a condition of interest. And it's worth thinking about this before you get started. So what are our conditions of interest for this analysis? What do we need in our analysis? In the original paper by Keras, there were 4 conditions. It was organized in what we call a 2x2 factorial design. We had voice leading stimuli, and we had mouth leading stimuli, and they were either audio or visual. So we've got 4 conditions. We've got mouth leading audio visual, voice leading audio, and voice leading audio visual. So to create that, we're going to need to put in our columns the type of stimulus, which is audio and audio visual, and we can see Excel's already found that. And we need to put as well the condition. And so we can now see that it's added an extra row, which is ML and VL, mouth leading audio, mouth leading or voice leading. Now, if you wanted it organized the other way around, so you had the top row being ML, VL, and the next ones being audio and audio visual, you can just change the order of these two, and you can see that it's changed that. So the next thing we need are our participants, who are going to be our rows. So if I scroll up and I take one of the ID columns, and here we go. We've got each row now as a participant, and we've got the columns which are the conditions of interest. Now, we said the correct answers were in the column correct, and they're 0s and 1s. And what we need to do is we need to calculate accuracy. We need to know, on average, what percentage did they get correct? And you'll probably think calculating a percentage, you normally have to take, for example, the amount that they did correct divided by the total number of stimuli. Another way to calculate accuracy, when it's calculated in 0s and 1s, you can just average all the 0s and 1s. And it does. You can try it out for yourself in Excel. It does the exact same thing. If you take an average of all the 0s and 1s, that will give you a value scaled between 0 and 1, which is actually your percentage. The only difference being that it will be 0 point something rather than 100% or whatever number. I'll just show you what that means. So I'm going to take correct, and I'm going to drag correct into values. By default, it's given me the sum, which isn't what I want. So I'm going to change that to the average. And I did that by clicking the I next to sum of correct. So if I click on OK, you can see I now have all of these values which are scaled between 0 and 1. Now in this case, we can see a number 0.3222 recurring. That's 32.22%. So to change this to a more traditional percentage, you would multiply it by 100. That's the only thing you would have to do. You'll see that actually in a lot of papers, scientists can't be bothered to make that extra step, so they'll just leave it as something scaled between 0 and 1, which is what I'm going to do for this analysis. But anyway, we've done our pre-processing. A couple clicks, a couple drags of different columns into different fields, and we're done. Although we're not exactly correct. So if we think about the Karras paper, they looked at the accuracy only for noisy trials. So we need to add in a couple filters to really recreate that. So I'm dragging the noise into the filter, and that's now come up in the corner here. So I can just select, I only want trials where noise was a Y. So where noise equals yes. And that's changed our accuracy, obviously, now, because we're only considering these difficult trials. So that accuracy beforehand, that was 32%. Accuracy's dropped down now to 23%, which makes sense because these were the more difficult trials. So are we finished? No, because I've actually made a mistake here. If I look back at the spreadsheet and we look here at the correct column, we're taking every 0 and 1 in this column right now. The only thing we're filtering for are the trials where noise has a Y in it, so noisy trials. But you can see there are all these zeros here. For example, there's a 0 value for the continue button. There's a 0 value for fixation, and there's a 0 value for response. But that one's correct. That's actually where they've made a response. So that should be a 1 or a 0. But all these other zeros in between, they're not correct. The correct values aren't correct. So we need to filter out all those extra zeros. We only care about zeros when the zone type was response text entry. So if we come back to our pivot table, and we just need to add in one more filter now under zone type. And this time, we're going to say only calculate averages for the response text entry boxes. And now you can see accuracy has shot up. So now accuracy is 46%. So much higher in that case. But that's it. So the only thing we would need to do now is copy and paste these into a new spreadsheet. And we're going to save that spreadsheet as a CSV file, which can be loaded into JASP. So in this case, copy. I've got a new spreadsheet open on the next desktop. And as per usual, I usually do paste just values to make sure we're not taking in any unnecessary information. And we need to give this label. So this was ID. This, what was that column actually? ML auditory and ML visual. So ML auditory, ML AV. And I'm just going to go back now and copy this one as well. There we go, we have VL auditory and VL AV. And there we go. We could also, at this point, if you wanted, download our demographics file, and we could look at the demographics file, and we could look at each ID code and calculate for each ID code whether the participant was male, female, how old they were, any extra information that we got from our demographics, and we could add that into this spreadsheet. But for the moment, I'm just going to look at the main analysis type. Here's the exact same file that I've just created, but this is it loaded in JASP. Now, I've mentioned already this was a 2x2 factorial design. So the best way to analyze this kind of factorial data is to do what's called a repeated measures ANOVA. And we have our different columns in here. Again, we have our live preview in here, which is going to update once we add in information. And then here we have our factors, and these can all be relabeled to make them useful. So I can say, for example, condition, ML and VL. Those are our two conditions, and then I have our stimulus, which is the second factor. And now that I've just hit enter after typing in stimulus, it comes up with two new levels. So I can say audio and audio-visual. And you can see that JASP has automatically created the variables here. So it says in this one, you want to put in your ML audio data. In this cell, you want to put in your ML audiovisual, and so on. And in this case, it's quite nice and easy because I can select all of them, and I can click the arrow. If they weren't in the correct order, you can drag and drop each one separately. And there we go. Our analysis is done. And what we can see here, there's no effect of condition. So that was not significant. And that means there was no significant difference between audio and between mouth leading and the voice leading stimuli. Actually, do you know what? I think it's always good to have a plot. So let's put in a plot now so we can see the data, and that's going to help us understand what we see in our results table. So we can have, for example, a condition and our stimulus, and I'm going to add in error bars. And if you want as well, you can write in a label. And there we go. So it's created, we've got our mouth leading, voice leading, and we've got our two stimuli, audio and audio visual. And this actually highlights the next point really well. There's a very significant main effect of stimulus. And that means that in this case, that the audio-visual trials, people were far more accurate than the audio files. And this was something that it makes sense based on previous literature. It's literally the first line of the Karras paper, which says that people are more accurate at speech perception when they can look at someone's mouth, when they have some kind of audio input, rather than just, one kind of visual input, rather than just relying on an audio input. But we can see here that condition effect I spoke about just now. There's not really any difference in each of these between the mouth leading words and the voice leading words. The final part is the interaction effect. And there's not really any interaction effect here. And that's a shame because that was actually what the Karras paper found. Their key finding was that there was the audio-visual trials, there was how do I phrase that? There was a greater benefit for visual information when the word was mouth leading compared to when the word was voice leading. That was their key effect that they found in their behavioral analysis. You can look at figure 2 plots, but we don't see that here. So we weren't able to fully replicate the results in this case. Now, what I'm going to show you in the next more advanced analysis, I'm going to show some extra tips and tricks because there were some elements that they mentioned in the Karras paper to do with their data analysis. For example, they allowed people to use plurals. They said if somebody said vacuums rather than vacuum, that could be considered correct, whereas Gorilla would not mark that as correct straight away. So what you're going to see in the advanced R script that I'm going to show you is a bunch of different text editing tools that are going to help give us a bit more leeway and allow us to account for some basically typos, differences in caps locks, accidentally adding punctuation, or these little changes like pluralizing, making the words a plural. See you in the next video.